Topic: Stoichiometry. Aims of lesson. To introduce the concept of empirical formula. To calculate the empirical formula of a substance by 1. Using the percentage composition. 2. Calculating the number of moles of each element. Introduction. To calculate the number of moles. In words, number of moles, N, equals mass, G, over molar mass, G bullet operator mole minus 1. Where N equals number of moles measured in mole. M equals mass of substance measured in grams, G. M equals molar mass measured in grams per mole, G bullet operator mole 1. Concepts and skills. The empirical formula. Definition. The empirical formula of a chemical compound is the simplest, whole number ratio in which different elements have combined in a compound. Can you calculate the number of moles using the mass and molar mass of a substance? To calculate 1. The percentage composition of the compound must be known. 2. Assume that you have 100 G, which is reflected as percent of the substance. 3. Use the percent amounts as amounts in grams, G. 4. Convert the grams to moles for each element, using the atomic mass of each element as indicated on the periodic table. 5. Divide each mole value by the smallest mole value. 6. Ensure that you round off to whole numbers. 7. The answers represent the mole ratio of each element in the empirical formula. 8. Write the empirical formula using the mole ratios. Worked example 1. Find the empirical formula for a compound consisting of 63% Mn and 37% O. Solution. Assume that a 100 G sample of the compound contains 63 G of Mn and 37 G of O. Please note, 63% plus 37% equals 100%. Calculate the number of moles of each element. Empirical formula equals Mn1O2. Identify the atomic masses by using the periodic table. Equals MnO2. Worked example 2. A compound consists of 26, 67% carbon, 71, 11% oxygen and 2, 22% hydrogen per mass. Calculate the empirical formula of the compound. Solution. Empirical formula equals C1O2H1 equals CO2H. The molecular formula. Sometimes referred to as the actual formula of the compound. It can sometimes be the same as the empirical formula, which is the simplest ratio of the elements, or an integral multiple of the empirical formula. Can be calculated if the molar mass of the compound is given as well. Refer to worked example 2. Calculate the molecular formula of CO2H if it is assumed that the molar mass is 90 G bullet operator mole 1. M, CO2H, equals 1xC plus 2xO plus 1xH. Equals 12 plus 2 by 16 plus 1. Equals 45 G bullet operator mole 1. Then the molecular formula contains twice as many atoms of each type. Molecular formula equals C2O4H2. Please note. Consult the periodic table for the correct atomic masses of each element. Ensure that you round off your mole values to get whole number ratios. Do not confuse the masses provided with the atomic masses. Read the questions carefully. Activity/assessment. Activity. 1. Calculate the empirical formula of compound A that contains 39.7% oxygen and 63% magnesium. 2. Determine the empirical formula for each compound with the given percent composition by mass. 2.124 for % calcium, 17, 1% nitrogen and 58, 5% oxygen. 2.226, 53% K, 35, 37% Cr, 38, 1% O. 3. Vinegar, which is used in our homes, is a dilute form of acetic acid. A sample of acetic acid has the following percentage composition: 39, 9% carbon, 6, 7% hydrogen and 53, 4% oxygen. Determine the empirical formula of acetic acid. 4. Nicotine is an addictive substance. An analysis of nicotine in cigarettes showed that it contains 74% carbon, 8, 7% hydrogen and 17, 3% nitrogen. 4.1 Determine the empirical formula of nicotine. Show all your calculations. 4.2 If the molar mass of nicotine is 162 gmol1, determine its molecular formula. Consolidation. You can now calculate the empirical formula of a substance by using its percentage composition and using your chemical calculations. Please note that you have to follow the steps as per the worked example solutions. Good luck with the lesson. Values. Consistency and independence are the values specific for the lesson. You must follow the rules and learn to work on your own.